my name is Diana Del Angel, and this talk is titled Communicating the Socioeconomic Impacts of Storm Surge Floodplains under the Coastal Dynamics of Sea Level Rise in the Northern Gulf of Mexico. The key research question of this project is what is the expected economic impact and exposure for coastal communities to a 100-year and 500-year stillwater floodplain under sea level rise? We focused on 4 different sea level rise scenarios for the year 2100. This work is part of a broader research program and builds upon years of work and numerous studies in the topics of hydrodynamics, morphology, ecology, remote sensing, wetlands, and communication and engagement. You can visit the link below to learn more about some of the publications associated with this project. Focusing on the economic valuation and development management tools is what I will be talking about today. And I will specifically talk about the stakeholder engagement, identifying the data needs and tools, and conducting the actual analysis, data visualization, and development of tools and web applications. The goal of our stakeholder engagement was to, one, educate the stakeholders on the approaches that we are using throughout this analysis, capture the stakeholder perspective and their understanding of the work that is ongoing, and to capture their preferences in data visualization. In our first workshop in Apalachicola Bay, NER, in 2017, we introduced the HAZUS application, which is the tool that we use to analyze the economic impacts. We introduced the inputs and assumptions in a sample application. In 2018, we provided preliminary results that the stakeholders were able to engage with. There were group discussions and focus groups where we were able to gather information they had, uncertainty about certain data, and how they would like this information communicated to them. In 2019, we brought back more data in different formats for data exploration, and we tried to identify which were the visualizations that they preferred, considering the potential uses that they had for this data. For the analysis itself, it was mostly performed with HAZUS. This is a FEMA GIS-based estimation tool, which helps relate the depth of flooding to damages. For this project, we used version 4.2, and one exception was roads and crops. We did these analyses outside of HAZUS. These are the components for the economic analysis. It included building and content losses, roads and bridges, crops, vehicles, essential or critical facilities, displaced people, and shelter needs. Our study site covers 15 counties in the northern Gulf of Mexico, and we settled on using this 10 square kilometer hexagon grid to tie the economic assessment results to. This grid helps give us a regional approach, and it's easier to manage on a web application. The slide here shows a snapshot of our results, which can be visualized in tables, graphs, and map form. And presented here are the damage potential results for the 100-year floodplain in billions in the graph below, for present day and the 4 sea level rise scenarios. The map above highlights the hexagon grid, and it compares present day scenario with a 0.5 meter sea level rise. The intensity of the red color highlights the increasing economic impact in percentage. The white cells also help us identify areas of new inundation where sea level rise has expanded the floodplain. Currently, we are working on our solutions platform. The goal of the platform is to provide plain language communication of our results and try to do this for such a very large data set. Again, we have buildings, building loss, number of buildings, displaced people, critical facilities, roads and bridges, and we're working with 10 different scenarios. In the snapshot shown here, you can see there are the different scenarios on top, and they have incorporated some bookmarks for ease of navigation. In addition, there are other functionality that we want this tool to have. For example, different tools for visualization, such as charts, maps, counters, pop-ups, as well as windows that provide detail as you hover over specific hexagons. In addition, we want to be able to provide a data export ability in this tool, as well as adding other relevant data that can help in the visualizations, such as evacuation routes and political boundaries. We've had, of course, a number of challenges with this project, including data availability, accessibility, trying to meet the diverse need of our stakeholders, and creating products that are feasible to model at a reasonable time and usable at various spatial scales. And also developing a tool that is simple for viewers, but still conveys a large amount of information. I think there are opportunities to expand research into policy analysis, social sciences, and I think there are many opportunities to integrate data scientists into our work. And I want to end with our key successes. I think we've gained an understanding of the nonlinearity of the socioeconomic impacts of storm surge under sea level rise. I think we've been able to highlight vulnerable areas, not only now, but under different sea level rise scenarios. And we learned a lot about the data needs and opportunities to enhance this data throughout this process. And even though it is in progress, I will count as this a success is the development of this visual communication tool. This is an acknowledgement to our funders and the literature cited. Thank you for your time.